Welcome to lecture 6. So today in this lecture, first we'll discuss about Zener Diode. So what is a Zener Diode? If you look at its symbol, it is represented by this symbol. This is the positive end and this is the negative end. Now, comparing a Zener diode with a normal diode, you could easily explain its properties. So, let us compare it with a normal diode. In Zener diode operates in both forward and reverse bias condition. But a normal diode operates, as you know from lecture 2, operates only in forward bias condition. Now, why Zener diode operates both in forward and reverse bias condition? Because in Zener diode, if you examine its p-n structure, there is a depletion layer present here near the junction of the P and N semiconductor. Therefore, it operates in forward direction as well as in reverse bias condition. So, but as we know, a diode in forward bias condition has a voltage drop of 0.7 volts in case of silicon. In the same way, in Zener diode also, in forward bias condition there is a voltage drop of 0.7 volts. But in reverse bias condition there is a voltage drop of 4.3 volts. So this is the difference between a Zener diode and a normal diode. In Zener diode there is a depletion layer present. In normal diode there is no depletion layer. In Zener diode it operates in both forward and reverse direction. In normal diode operates only in forward bias condition. In Zener diode the reverse voltage drop is 4.3 volts, but in reverse bias condition a normal diode does not operate. Now let us examine the VI characteristics or the voltage current characteristics of a Zener diode. VI characteristics of a Zener diode. So this is the current graph and this is the voltage axis. So in forward bias condition at from 0.7 volts it starts conducting. And this is the forward region. This is the forward region. But in reverse bias condition, this is 4.3 volts, minus 4.3 volts, because it is in the reverse direction. So it starts conducting from 4.3 volts. This is the reverse region. Now, at this 0.7 volt and exactly at this 4.3 volts, these are called as knee voltages. At this point, the Zener diode starts conducting in the reverse direction, and at this point, the Zener diode starts conducting in the forward direction. Now let us compare the VI characteristics of diode, normal diode with Zener diode. Normal diode also behaves in this manner in the forward direction, but in reverse bias condition it does not conduct and reaches a breakdown point where the diode destroys. So we are clear about the VI characteristics of a Zener diode. Now let us move on to the application of Zener diode. Now talking about the application of Zener diode, as the Zener diode can operate both in forward and reverse direction, it is normally used in a voltage regulator circuit. In the application of Zener diode, it is used in a voltage regulator. Suppose we have a Zener diode present here and we have a AC signal. So the output would be, this will be the sine wave input, and the output will be clipped off. In the forward region, it becomes, this becomes positive and this becomes negative in the first half cycle, and this becomes positive, negative is connected to the positive, and positive is connected to the negative. So this is reverse bias. So in reverse bias condition, there is a very low voltage leakage. So in the first half cycle, there will be, in the second half cycle, they will be showing in this manner, because in the first half cycle it is reverse bias. So if it would be a normal diode, it will be open circuit and the entire voltage will be passed. But as it is a Zener diode, so 4.3 volts of voltage drop is experienced. So from this volt, 4.3 volts is subtracted, and the rest of the voltage is present here. So this is the voltage which is, and this is the voltage which is passed. Now in the negative half cycle, this is forward bias, this is negative and this is positive. So in forward bias condition, this behaves as a short circuit. So in short circuit, the current passes in this manner and does not flows, but due to a voltage drop of 0.7 volts, a little current is passed. This circuit will also explain in multisim in the next section. Now let us examine another voltage regulator circuit, which is called as the double Zener diode voltage regulator circuit. We have two Zener diodes present in this manner and connected with a resistance in series and to the input source in parallel. So let us examine how does it operates. This is Zener diode 1 and Zener diode 2, and this is the load resistance RL. And here the breakdown voltage for the Zener breakdown is 4.3 volts and avalanche breakdown is 0.7 volts. Avalanche breakdown is the breakdown which is caused in reverse bias condition, that is the 4.3 volts which we have explained in the graph, and the Zener breakdown occurs at the Zener breakdown occurs as 4.3 volts and the avalanche breakdown occurs in 0.7 volts, that is in the forward bias condition. So the avalanche breakdown and the Zener breakdown of these two Zener diodes are equal. Now let us observe its output. So this is the input signal and this is the output signal. So in the first half cycle, this one is forward bias and this one is reverse bias, because the positive is connected to the positive and here but the negative is connected to the positive. So when this is forward bias, the voltage drop of 0.7 volt is observed, and here as it is reverse bias, the voltage drop of 4.3 is observed. So in total there is a voltage drop of 5 volts. So in the first half cycle, a 5 volt drop is seen as compared to the input signal. Now let us move on to the second half cycle. In the second half cycle, negative is connected to the positive and here positive is connected to negative. Therefore, this is reverse bias and this is forward bias. Here there is a voltage drop of 4.3 volts and here there is a voltage drop of 0.7 volts. There also there is a 5 volt drop. So here is the output. So there is a 5 volt drop also in the negative half cycle. So we could say that this double Zener diode input signal from both the sections equally if the average breakdown and the general breakdown voltages are equal for both this diode. So let us observe this in Multisim 14.1. It's a simulation software which we have discussed in the first lecture, and we'll see whether this theoretical concepts holds good in the practical terms and whether these kind of outputs are observed if we do it in Multisim or not. So let's see. So guys, this is the Multisim software. We have also used this earlier in lecture 1. Now we'll construct the Zener diode application. Now this is the diode section where we'll choose the Zener diode and we'll take the first one. Then we'll choose the power supply, that is from the power source. We'll take AC power. Then we'll take a resistance of 1 kilo ohm here by clicking on the resistor, and 1 kilo ohm from here. By pressing OK, we'll have this resistor will drop here. Now we'll connect this, the positive to the negative of the Zener diode and negative to the positive. Now we'll take the oscilloscope present here and we'll put it here, and the positive will connect it to the positive and negative to the negative of the Zener diode. Now we'll run it and we'll see the output. Now you could see that could increase the value so that the waveform is clear, and to examine this we will pause the simulation. Now you could see from the voltage of 120 volts or the 120 RMS voltage in the first half cycle, it is in reverse bias condition, and in the negative half cycle it is in forward bias condition. So in reverse bias condition there is a high voltage drop. You could see there is a very high voltage drop from input signal, but in the forward bias condition there is a very low voltage drop of 0.7 volts. So here is a voltage drop of 0.7 volts and here is a voltage drop of 4.3 volts. Therefore this is the resultant output. Now let us move on to the next application, that is the use of Zener diode in voltage regulator, which I have explained it just now. For that we need two Zener diode. So therefore first you have to stop the simulation. After that only we could change or alter the simulations or the simulated. By pressing Ctrl R, you could rotate any of these components, and you can also cut, copy or paste these components in Multisim by using your general Ctrl C, Ctrl V or Ctrl X. But to rotate it you should press Ctrl R. Now let us see how does this operates. It is very high voltage, so we need to put. Now you could see both the upper and the lower half, or the upper or the lower half cycles are clipped off, as we have seen in the lecture, in the theory in the board. The upper half as well as the lower half with a voltage drop of the Zener voltage plus the avalanche voltage. Now it is proved that the theory which I have taught you just now is practically applicable in regulating the voltage. So this is the application of Zener diode. Now lecture 6 of module 1, we discussed about the Zener diode, its comparison with normal diode, working principle, as well as its Zener breakdown as well as average breakdown, comparing it with conventional diode. We also discussed the practical point of view or a simulation in Multisim 14.1, where we constructed the theoretical application by making use of the software. Also we analyzed how does it operates when a voltage source is given to a Zener clipper, where it clips the forward as well as clips the upper half as well as the lower half, by making it a voltage regulator circuit. So in the next class we will be discussing about, we will be going deep into the bipolar junction transistor, and we will discuss the NPN and PNP types of transistors and their further applications and circuits. So if you find this video informative, please hit the like button. If you have any doubts, write to us in the comment section and subscribe the channel to stay connected with this.